In this next section, I want to talk about computer networking job specialties. So if you are fortunate enough to work for a company that has a really large network and a large IT department, you might be fortunate to be able to specialize in a certain job role. And if you're pursuing a Cisco certification, so if you go to Cisco's website, and I'll show this to you in a little bit in the next video, you'll see they have certifications that fall in line with these types of specialties. And so now I'd like to talk a little bit about what do those specialties mean. So if you get a certification for collaboration or routing and switching or security, what are you expected to be able to do with that kind of a knowledge? So here we have, once again, our network. And as I mentioned earlier, a lot of network administrators and network engineers are expected to know pretty much everything. They're expected to know how to do routing and switching. They're expected to know how to implement the voice and video, how to do the security. But let's break this up into different components. Starting with routing and switching. Okay. So if you are, let's go back to that. If you are a network engineer or network admin and you are able to specialize in routing and switching, your specialty is really knowing how to get data from point A to point B in the most efficient and optimized way across the network. So that's one thing. Your specialty will be knowing, all right, how do I get this network to learn about all the different paths through it? How do I get these routers to understand that there's multiple paths? How do I get them to select the best path? And if I want to influence that, how do I influence it? If I want to filter out certain paths where routers know about some paths but they don't know about others, how do I do that? A routing and switching specialist will have answers to those questions. Enabling the network to differentiate between different types of data and treat each according to prescribed requirements. So in the case of a routing and switching specialist, someone might come to you and say, okay, this network we have has web browsing traffic going across it, as well as people doing their file transfers. And the file transfers are much more important to us on our company than web browsing. Web browsing is important too, but if something has to suffer, we'd rather have the web browsing suffer rather than the file transfer suffer. So you as a routing and switching specialist would have to know, all right, how do I program the routers and switches to be able to differentiate between the web browsing traffic and the file transfer traffic? And now they've differentiated between those two types of traffic. What features can I turn on? How can I configure things so that the file transfer traffic will always have priority? Will always take the absolute best paths, will always be treated the best. So routing and switching will have to know how to do that. Identifying various ways to partition networks for basic security requirements and scalability. That's another thing in routing and switching that you would have to know. This comes into the whole idea of IP addressing and subnetting and implementing basic security so that to restrict traffic between subnets. All right, what about security? As a security specialist in a network, you'll be in charge of identifying and protecting against security threats. So you'll have to research what are the current security threats out there? What are people doing to try to bring down web servers, to try to bring down calendaring or file servers? How are they accomplishing that? And using my routers and switches and other types of specialized security hardware, how can I prevent those types of attacks from influencing and affecting my network? How do I spot those attacks? What does the traffic pattern look like when an attack is going on? And how do I stop it? How do I identify it? Implementation of security devices such as firewalls, intrusion detection, VPNs, and more. So once again, the idea here behind a security specialist is identifying where the attacks might come from. What types of attacks could I expect to come from outside my network, like from the public, versus what types of attacks might happen internally in my network. Sometimes attacks are not intentional. Sometimes people just accidentally do things. They don't understand what they're doing, but it causes a network attack. So you as a security specialist have to be able to predict that, predict where these types of things might come from, and secure your network against that type of problem. And device hardening. How do I make sure that only my authorized users can actually get access to the command line of the routers and switches. I don't want any employee within my company being able to get the command line of my router switch and start messing around with features and blow out the whole network. I only want authorized people who know what they're doing. So how do I do that? How do I implement that? The network security specialist will be able to answer those questions. Data center. Unify storage, computing, and network resources to simplify a data center and utilize technologies including policy-driven infrastructure. So what's that? Policy-driven infrastructure. So the idea here is we have a policy. In other words, in our data center, we have certain types of data that should take certain paths, other types of data that should be allowed a certain amount of the network it can use. So that policy drives how we build out the infrastructure, what switches we select, what types of interfaces we select, how we derive our redundancy and resiliency to meet the needs of our policy. Virtualization, automation and orchestration, unified computing, data center security, and integration of cloud initiatives. So like I mentioned way back a couple of videos ago where I described what a data center is, the data center specialist will be very familiar with all the ways that these high-end servers can connect to a network, picking the method, the NIC card and the cabling that is the fastest, that's the most effective and efficient, that provides the most redundancy and resiliency, picking the networking devices like the switches and routers that are optimized to connect to these servers. They have certain features and protocols running so the servers can be accessed as quickly as possible. And so if one server fails, the network can very quickly fail over to another server. So a data center specialist will be very familiar with the data center. What's happening in the data center? How is everything connected? And how do we get to it in the fastest, most reliable way possible? That's a data center specialist. Data center absolutely requires that you have a lot of knowledge of servers. So if you're thinking, well, I just want to learn about routers and switches, this is not for you. So data center definitely goes beyond just knowing routing and switching, and you have to know something about servers and how servers operate and the types of hardware you can find on servers so you can integrate the servers with the network. Then we also have collaboration. So I mentioned earlier that collaboration is this idea of taking my existing network that has my data running on it, like my web browsing, my file transfer, and adding on top of that network, using it for additional things like transferring my voice calls, my telephones, and transferring video sessions so people can have telecommuting conferences, so they can bring up Skype, so they can bring up WebEx and other types of telepresence solutions. So someone who's very specialized in collaboration will be able to implement that. They'll know, okay, when I put my IP phones, when I connect them to the network, how can I isolate the IP phone traffic so that it is given a higher priority, better service than everything else, because my voice traffic is critical to me. How do I have my IP phones call one another? You know, how do I create what's called a dial plan so that when I pick up my IP phone, users know they need to dial 4 digits or 7 digits or 9 digits? And how does one IP phone connect to another IP phone? Is there a central server somewhere that all IP phones have to connect to first, and that central server knows how to direct calls? Well, how do I configure that server for that? As far as video is concerned, a collaboration specialist will know, okay, how do I take my digital camera that actually has an Ethernet connection in it and connect it into the network? How do I optimize the network so that video flowing across the network won't completely overwhelm the network? Because video uses a lot of network resources, a lot of bandwidth. How do I tailor the network so the video is nice and streamlined? It's not choppy, it's not fuzzy, it's just crystal clear like HD video. Where do I put my video servers? How do I give my users access to recorded videos? All of that is something that in collaboration you would specialize in. And then of course there's wireless. Pretty much almost every network these days has some component of Wi-Fi in it. So someone who specializes in wireless will be able to answer things like, okay, I know that I need access points to connect to my users. Number one, what kind of Wi-Fi NIC cards do I want my users to have? If I have a choice, if I have a bunch of laptops and PCs, you have a choice of what kind of NIC card you want to stick in those things. So you should know the differences between them, the various features they support. There's a whole bunch of different access points out there. The wireless specialist will know what makes access points different from each other. Why would I want to put one type of access point outside my building versus another one inside my building? And how can I tell the difference between outside and inside access points? How many access points do I need? Will just one cover it for my entire building, or do I need one every 20 feet? You know, how many people do I have in this section of the building? Because the quantity of people, the quantity of filing cabinets and desks and metal walls will determine how many access points I need, where they need to be placed so they can hear everything. How about when those access points connect to the infrastructure of the network? How do I want to do that? What's the most efficient way so the access points can talk to each other and talk back to some central server that's monitoring and managing all of my Wi-Fi traffic? So a wireless specialist will deal with that. And then there's service provider. So someone who specializes in service provider is most likely going to be a network admin or engineer that's actually working for a service provider. And what I mean by that is someone who's working inside of Time Warner Cable, working inside of Comcast or AT&T and working on their network. Now those types of networks at AT&T or Time Warner Cable or Comcast are optimized not only for their own internal employees, because for example, at Time Warner Cable, they've got their own payroll department, they got their own marketing, they got their own email, so their network has to carry that traffic. But that network is also carrying traffic between different service providers. It's carrying massive amount of traffic from certain parts of the country to other parts of the country, certain parts of the world to other parts of the world. So now we're talking about a network that's carrying orders of magnitude more traffic than a typical LAN would in just an enterprise customer. So a service provider engineer needs to know, how do I optimize this network so this massive amount of traffic can flow through it? This network that when a piece of information comes in, there might be 1,000 different ways to get that information to its destination. How do I configure the network so it takes the most optimized way when there's tons of ways? How do I get the network so that when it learns of all these paths to different destinations, it can handle it? It doesn't get overwhelmed, and it logically figures out the best path. How do I secure a network like that? How do I implement features and policies like QoS and MPLS and VPNs and carrier Ethernet? All of those are terms that a service provider network engineer would need to know. So that gives you some idea, and there's even beyond that. There's other specialties as well, for example, cloud engineers and cryptography engineers, but these are some of the sort of high-level specialties that you could branch off into once you've been a network admin for a handful of years. So that concludes this video. In the last video I'm going to do, the one coming up, I'm going to answer the question, where do I go from here?